Welcome to a short addendum to the last video on TensorFlow 2. I just finished this video and I thought about give you a look if you set the node degree manually instead of 1 to 0. We calculate the graph. Now we do have 403 nodes. Well, never mind. And let's see the result. Yes, okay, there's a node C, no precision, no problem. And yep, hey, there's something. Okay, I get it. Yeah, no problem at all. There should be yellow, network should be yellow, health should be yellow, social. But you get it, yeah? If you have now, for example, water here in this vicinity, you all have the words that are in the epsilon vicinity of water given the TensorFlow 2 word2vec calculation. In a 128-dimensional embedding, we calculated the cosine similarity of the top 100 words close to those 128-dimensional representation of water in a topological space. And those are the words. And then we had some other words like transport, mobility, city, singular, health, networks, and social. And they are interlinks now between words in the vicinity of water with, I don't know, the vicinity of the word transport. And this vicinity you can see here. There's also the target word air. To make it a little bit clearer, I think we go in a 3-dimensional representation. Let's jump in 3-dimension. Come on. Calculated it. And a graph visualization with the algorithm of Force Atlas 2. It's a very simple algorithm I've written. There's nothing special about it. Just can input here my parameters, my opacity line, my width factor, my font size, the scale factor, the line width, my iteration, which is essential if you have a more complex problem you encounter. But this should be done very soon. And again, you have two input parameters. This is the lower threshold and the upper threshold that I want to take into consideration. And in my case, close to 9 GB. Yes, it takes a little bit of memory to calculate it. So our threshold is 0 and our upper threshold is 1, of course. We're not interested in all the blah, 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 blah. We create an external file. Here, graph09. We go to our file. We make readings. Yes. And we download it. So I can show you. Yes, open with Firefox, of course. Where else do I think I want to open it? And it takes about 15 seconds, so hold on, I'm back in 10 seconds. And we are live again, and this is exactly now in 3-dimension, in an interactive 3-dimensional representation. And what you see here now are targets words like health, social, urban, pollution, water, transport, air, and mobility. Where's mobility? Here's mobility. That now you can see the interlinks. And I don't know what we chose. What shall we choose? Help me. Transport. No, health. No, not really. Political. No, I don't want to go for some political. Interesting things about the political system. No, thank you. Mobility, urban. Yeah, I don't know. Health. Agriculture. No, definitely not agriculture. So what are we looking for? Yes. I don't know. Yeah, stop it. So here we go. And I am with water. So I have here two target words. One is pollution and one is water. And as you can see here, we have for water here a bouquet of words that are in the vicinity, in the epsilon vicinity of the calculation in a 128-dimensional space, which resulted from the weights of our hidden layer of our shallow neural network. And we have taken the top 100 words that are closest to water, here all the words. And then we have, of course, another target word like pollution. And we've done the same with top 100 words that are semantically close to pollution within our TensorFlow calculation of word2vec. Now, the interesting thing is the words that are in the vicinity of water and in the vicinity of pollution. And those are the words here, for example. Let's zoom in a little bit that we can see it. You can see that soil, monitoring, dioxide, and purification is both here in the learned representation of a neural network of water and pollution. And of course, you can have that if you have multiple target words, here we add now air, that you have here the word pollutants that have a link to water, pollution, and air. So this is what I'm interested in, the multiple interlinks in the system I want to understand. And a very nice aspect of this is, and I want to show this here, I don't know, we have now here, we take here a word like, I don't know, irrigation. Irrigation here, of course, within the vicinity of water. And let's say we have pollution, and you see that irrigation and pollution currently has no direct link between those words. And you can now have yourself, you analyze, hey, would it be of interest, let's say, for a new research project, for a new political initiative, for the new whatever you want to do, that you say, hey, I have here remediation, and I don't know, I have here some aquatic environments or whatever. Is there a missing link that I should establish? So you can really easily check out if, like here in these 34,000 research projects, of course, I have only chosen to take the 100 words of it. So our vocabulary has a strength of 50,000 words, but just here for the visualization purpose of some demonstration, I'm gonna show you the idea, and you focus on your words, you focus on your very specific detail, and you can ask yourself, hey, is there a chance that maybe the membrane technology I have here has some application in some agricultural pollution R&D, or what has urbanization to do, and why is a link missing to, I don't know, what we have down there. Oops, wrong direction. Why is a link missing to health? So this opens up a very nice perspective, I find, if I try to analyze some problems and I see, okay, on a meta level, on a very top level, there seem to be some missing links that are not as strong as maybe they should be. Networks, of course, learning, social, there is a very established link. You can also have here the width of the link. You can give them the weight of the edge. You can encode in different colors and different sizes and whatsoever. You can play around, and you can really have a very nice insights with this three-dimensional representation to understand maybe there are missing links somewhere. Like here from urban to health, you see that you have here some nodes, but agenda, sustainable, provision, related. Well, I wouldn't say that this is essential. I mean, this is typical. Yes, whatever, no? Maybe there should be some other topics, some other nodes in the future that some R&D is necessary, or maybe would increase our social inclusion or whatsoever. So it's a very nice tool to get an insight, to play around a little bit, to challenge yourself, to augment your knowledge, to augment your insights. And I just wanted to show this, that it's very easy to be done if you have the TensorFlow calculation of word2vec, and you get some very nice insights into your documents. This was it for today. It was just a short addendum. Sorry for the short interrupt, but I thought it would be maybe of interest to you. Thank you. See you next time.